So now let us look into the next exercise, developing word count program. Word count is nothing but for each unique word, we have to get how many times it is repeated. Okay, so data is available in this HDFS location in the lab. If you are using local environment or your own environment, you need to generate this test data. You can get it from wherever you want. Because it's 30 GB worth of data, I will not be able to share it in GitHub and all. So I will leave it to you about how you will be creating that 30 GB worth of data. That being said, let me show you some important information on this data set. You can see there are a number of files here starting from 0 to 29, which means 30 files, and each file is almost of 1 GB. So we can actually say -ls -h and hit enter. So we have 30 GB worth of data, and we have to process this 30 GB data. And as part of the problem statement, we also got how many number of executors should be used, how much memory should be used, how many cores should be used, and what should be the number of output files that needs to be created. So these three things are pretty straightforward, and we have been seeing with other problem statements, even though they are not so much important. We just started using those things by understanding the data more accurately than just using the defaults. In this case, it is specific that we have to use these settings. So let's start creating the Spark Shell command. Okay, so Spark Shell command should look like this: master yarn, and then this is specific to my environment, the big data labs which we are using. For other environments, it might not be that relevant, but if you are using lab which is multi-tenant environment, you have to use a 5-digit number from 10,000 to 65,535 so that your program runs without any issues. But for certification, it is not that important. And then num executors is the one which will control the number of executors, and there needs to be 10. And executor memory has to be 3 GB. And then executor cores, it is specified as 20. Hence, we have to give 2 for each executor. And that's it. Okay, if you could not recollect, you just go to the command line and say Spark Shell help, and it will give the details. So num executors is the one to get the number of executors, executor memory for the memory, and somewhere there should be executor cores also. Here you see executor cores. That being said, let me run this Spark Shell command. And also, to avoid any typos, especially when the questions are asked explicitly like this, we should review the resources that are allocated when the shell is started, even before we write the code. And that can be done using tracking URL. Okay, so we'll get tracking URL in a moment. Yeah, so this is the tracking URL. You can use this. And you can check the executors here. There are 10 of them, 1 to 9, and then 10 here. Also, you can go to environment and check executor memory is 3 GB and executor cores is 2. That being said, now we have to develop the logic for the word count. So when it comes to word count, especially if you look at the data, it's nothing but a free-flowing text like you see in Wikipedia or any text file format, where each word is separated by a space and each line is separated by a new line character. And from there, we have to get the word count, which is nothing but number of occurrences for each word. So first we need to read the data from the location which is specified as part of the problem statement. So I'm creating a variable called lines and then using se.text file and giving that path which is given as part of the problem statement, which is nothing but public/random text writer. Okay, and each line has to be splitted into words, and we should figure out a way to get the count. So if there is a line, something like this, val s equal to hello world, how are you? So this is a, let's take this is a line, and space is the delimiter between the word. And if I want to get individual words from this line, I can use split like this, which will create this string into an array using space as delimiter. And we have to use this logic as part of the transformation to get individual words. But if we use map and if we say s dot split like this, for each input line, you will get an array like this. Hence, you have to use flat map, where for each input record, which is line, we will get n number of records which are nothing but words. So for this line, there will be 5 records. So for that purpose, we have to use the API called flat map to flatten out the array. The rest of the stuff is same as map. Only thing is, instead of using map, we are using flat map, so that the array which will be the output after transformations such as split, we can flatten it out into multiple records. Okay, so we have to use flat map so that each line is flattened into words. So that's what I will be doing here. Val words equal to lines dot flat map line dot split. Okay, so let me paste this code and let us say words of take of 10 for each println, and you can see the data. Okay, for a given input record, there are these words flattened out because of the flat map using space as delimiter. Now we cannot add these words directly. We have to use APIs such as reduce by key, aggregate by key, etc. to perform any aggregation. And if you go through the documentation, reduce by key or aggregate by key requires the input to be in key value pairs or paired RDD. For that reason, we have to convert each of these strings into a tuples. And so for each input record, which is nothing but a word, I have to get a tuple. And for that, we need to use map. We take each word individually and we convert it into tuple. That's why I put it the brackets here. So as part of the tuple, we will get the word, because we have to get word count, which is nothing but number of repetitions for each word. And then we have to have the hardcode value 1, so that we can add these ones, holding each word as key, and get the number of occurrences. Okay, so we can run this. And then we can say tuples dot take of 10 for each println. You can see we got the tuple. Now I have to use reduce by key, and in this case, because it's simple addition, no need to get into aggregate by key to add these ones to get the word count. But the problem statement says the number of output files should be 8, and that is not covered yet. So there are multiple ways to do that, and also the target file format has to be Avro. It is not the typical text file format. So these two are the things which you need to keep in mind. Okay. So first, let us focus on number of output files should be 8. So there are many ways to do that. We can use as many tasks at each stage, and finally we can say coalesce and reduce the number of files to 8. That is one way of doing it. On top of it, if you look at the syntax of the transformation APIs, such as reduce by key, which result in shuffling, each of these things actually take an additional argument called numtask, which is optional. Distinct, group by key, reduce by key, aggregate by key, sort by key, join. All these things take an additional optional argument called numtasks. Okay, so we can use that to control the amount of resources that will be used in the downstream operations. If I leave it like this, it will actually use 270 tasks to process data in each stage. Now, I am leaving to default in the first stage, but when it comes to second stage, I want to use only 8 tasks to process the data, and it will only create 8 files in the end. Okay, so we can actually control here itself. So let me do it here. Now I can say val word count equal to tuples dot reduce by key. Okay, and then total comma subtotal implies total plus, or let me give it as value from the tuple, total plus value. That is the functionality for the first argument to just get the word count, and the second argument I want to pass numtasks to be 8. Okay, and reduce by key generates RDD, and we have to save the file in Avro file format. If we have to save the file in Avro file format, first we have to convert it into data frame. Okay, so any RDD can be converted into data frame. Okay, so here I am saying val word count df equal to word count dot to df. Okay, and I'm giving the names as word comma count, and it will create the data frame. So let us copy these things also. Now if you see word count df dot write dot tab, okay, you see file format or APIs for file formats such as Parquet, text, JSON, etc. But there is nothing for Avro. So most likely, if you are giving for CCA certification, Avro will be automatically integrated as part of the cluster. So you don't need to worry too much about it. But at the time of practice, Avro might not be available directly here. So if I say Avro and give the path, let me check the output path here. Okay, so this is the output path. Word count df dot write dot Avro, and let me use this code here. It says Avro is not a member of org.apache.spark.sql data frame writer. Most likely in Cloudera certification, you will not run into this issue. If you run into issue, definitely as part of the problem statement, they will provide you additional information which you need to know to get the API to write into Avro file format. Okay, so let me show you what that will be. So either they will say to use package like this. Okay, so I will add it to the problem statement. First, let me add the package to this. So they will say, okay, use packages with artifact ID com.databricks with group ID spark avro underscore 2.10 and version 2.0.1, or they might even give the jar file location. If they give jar file location, you just have to say hyphen jars and give the location in double quotes and whatever jar file they give. You don't need to include packages if they give jar file location. But if they give package information with the artifact ID, group ID, and version, this is how you have to define. So this is the artifact ID, com.databricks, this is group ID, and this is version. So that information will be provided. Well, either they will give the jar file location or they will give the package information. And you need to understand that packages, external packages can be read using hyphen packages, and jar files can be loaded using hyphen jars. So in this case, we'll be using packages. As the session is already started and I have killed, I can paste this and relaunch it again. And then you can see it actually download the dependencies from repositories over the internet, and then it launches the session. So on top of Spark UI, you can also see the executor's details in the logging information also. You can see that it has created executor on this IP address and on this port number. And if you see, there will be ID also associated with it. And there will be 10 executors because we have said number of executors as 10. Okay, and that being said, now if I run this code, because Avro is integrated, it will run without any issues. Okay, I know the problem. We also need to import com.databricks dot spark dot avro dot underscore. And now it will work. And now it is processing the data. Let me add this line also to the code, and it will take some time to run this logic because we are trying to process 30 GB of data. So it is still running. You can track the progress by going to jobs in the Spark UI. Okay, this is not the one. I'm looking at the wrong one because I killed the session and started it. It was showing the wrong one, but you can go to the Spark UI and get the information. Now data is loaded and the output will be in the Avro format. You can check whether 8 files are created or more created by going to the output location, which is specified as part of the solution, which is nothing but this one. Hadoop fs-ls, paste and hit enter. and you can see there are 8 files, and each of these files are nothing but of type Avro. Okay, and we will not be able to read data directly from here. If you want to see the output, again you have to use read API like this. So sc dot not sc.txt file, SQL context dot read dot Avro, and give the path, and then dot show, and hit enter, and it will show you the data. Don't worry about these special characters. This is just garbled data of 30 GB. And this is how you can actually get the word count with the custom control arguments, and also a bit of custom logic internally. And also we have used Avro file format to write the data into.